Alright folks, we're going to do multiplying special cases. These are shortcuts. These are not necessities. They do allow us later on to do things obviously much quicker. But if these are a result of essentially what we learned in section 8.3, so if you want to, on all of these, just use what we learned in 8.3, that is perfectly fine. But I will go through kind of the general processes here with you in these examples. This shouldn't be a very long video, and the homework again is not extensive. Okay, so first one is when we talk about squares of binomials. Remember what squaring something means. This ultimately means A plus B times A plus B. I think we all know that by now. Okay, so if that's the case, then use what we talked about in the 8.3 section, where I take that one. So I'm gonna distribute A to everything over here. So when I go A times A, that gives me A squared. When I go A times B, that gives me AB. Now when I take the second one and multiply there, B times A, it gives me BA, or I can write BA as AB as well. And then I go B times B, which will give me B squared. So what this means to me, if I look at these, if I add those together, those are the same. So remember, that was created by the O in foiling, and that was created by the I in foiling. O and I end up being the same term when we have something that looks like this. So what happens is we go to A squared plus 2ABs plus B squared. Okay? So then here's the argument. If I start with A plus B squared, if that's what I start with, a binomial squared, then you can square the first thing and square the last thing. Think about that. Take that and square it, you get A squared. Take that and square it, you get that. Okay? So, and remember, this is essentially the first times the first, and this is the last times the last. And then to get the middle part, all you've got to do is multiply those two numbers together, and that's going to give you that part, and then you double it. Okay, so that's kind of the shortcut for these. Okay, subtraction is really the same way. If I were to subtract these, A and B, so it's going to be A minus B times A minus B. So now, again, foiling, first times first, is A squared. Outside times outside, now it's a positive times a negative, so it's negative AB. And now if I go inside times inside, it's another negative AB. And then last times last, a negative times a negative gives me a positive B squared. Again then, this becomes A squared. These two things are the same, so it's negative 2AB when I combine like terms. And then plus B squared. Again, so I can square that, and it gives me that. Square that, it gives you that. Multiply these two numbers together, so it becomes a positive A times a negative B, that gives you negative AB, which is this part here. Then you double it. So that's kind of how I'm going to go through all these. You can check all these by obviously doing the foiling process, okay? But we'll run through a quick set of examples here. So just writing this above here. And I'm going to write the rule. There's two rules. It's adding and subtracting. So adding, subtracting, B squared. So what that's going to turn into is always an A squared, and then it'll be plus or minus whatever that sign was, 2ABs, and then it will always then be plus B squared. Okay, so when I square this, so square the x, square the 5. Okay. Now you're going to multiply those together, so it gives you 5x, and then you double 5x. So 5x doubled is 10x. Same thing here. Square that one, gives you x squared. Square that one, gives you 81. Okay. Multiply those together, so you get 9x, and then double the 9, it gives you 18. X minus 4 squared, square that one. Take the negative 4 and square it, so it gives you a positive 16. Multiply those together, so it gives you negative 4x, and then double it.
Individual regional administrators to make sure that the hospitals.
Alright, so I just brought Desmos up here, and you can check these. You can go x plus 5 and square it, and it gives you that curve right there. If I go x squared plus 10x plus 25, you notice it gets the exact same thing. So because they're the exact same graph, that means that these two things over here are the exact same relationship, or the exact same expression. Okay, just this one is what we call expanded form. All right. So we can go down. I'll do these other ones with you real quick. So it doesn't have to be just an x in this first spot. Okay. So remember what this means. This means 2a plus 3 times 2a plus 3. So I'll go back through with 8 3's information and see what the answer is. So we'll FOIL this. So first times first is 2a times 2a, which gives me a 4a squared. Remember, add the exponents when you multiply like bases. Outside times outside will give me a 6a. Okay. Now we'll go inside times inside, so there's another 6a. So there's where you see that doubling concept. And then last times last will give me 3 times 3, which is 9. So it gives me 4a squared plus 12a plus 9. So that's using 8 3's approach, which is perfectly fine if that's what you want to go with. But if you want to use the approach that is in 8 4 here with these shortcuts, remember you take that one and you square it. So 2 squared is 4, a squared is that. Okay? You're going to take the last number and square it. So it gives you 9. Okay? Now you're going to take 2a and 3 and multiply them together. So it gives you 6a. Then double the 6. So it gives you your 12a in the middle. And you notice that they are identical. Hopefully you view that the blue one was a little bit quicker to do. Okay? Same thing here. Square that. So if I square a negative x times negative x is a positive x. Okay? Square that. So plus 16. Now multiply these together and also negative 4x, and then double that will give you negative 8x. Okay? Something that my examples don't really get into, but it doesn't matter the order. So I could have written this as positive 4 minus x that way, squared. And if I square that first part, I get 16. Square this, you get positive x squared. Multiply together, get negative 4x, and then double it, gives you negative 8x. These two things are the same once you realize the commutative property and move things around. Do the next one. This is probably the hardest one on here because of the multiple variables, but it shouldn't really be a big issue. Negative y times negative y gives me positive y squared. Okay. I'm going to square this last one. So 3 squared is 9. T squared will be that. Now multiply these together. You get negative 3yt. Negative 3yt. And now you're going to double that. So it gives you negative 6yt. Again, you can use Desmos to check these. The only thing with Desmos, remember, it doesn't like you using x's and y's if you're going to substitute. And I think that's what you'd have to do on this one because of the extra variable. So maybe on Desmos you would type this in, maybe use y as a. Go a squared minus 6at plus 9t squared. It'll ask you to set a value for a. It'll ask you to set a value for t. And do that. And then also then type in negative a plus 3t squared. And you'll see that whatever that thing evaluates to will be the exact as whatever that evaluates to. So use that technology. I think that's going to help you in the long run. Okay. Something that is also very important is what we call the product of a sum and a difference. Okay. The product of a sum and a difference. So what's going to happen here is that you are going to have in your binomials are going to be the exact same things, a and b. Okay. But one of them is going to be an addition sign stuck between them. The other one's a minus sign. Okay. This is the sum. This is the product of a sum, which is right here, and a difference. Okay. Kind of see what happens when we do this. If I go a times a, that gives you a squared. A times negative b gives me negative ab. That's first. Times first, and outside times outside. Now I'll go inside times inside, so that's a positive BA, but I can rewrite it as AB. And then last times last will be negative B squared. What do you recognize about those two things? They should be opposites, and opposites go to 0. So you're left with A squared plus 0 minus then B squared. Alright, so you see the pattern here. You see if I started with A plus B, A minus B, okay, and I FOIL that, the two terms that are made by O and I end up being opposites. And opposites through addition cancel each other out, go to 0. So what happens if I'm able to recognize that this is a sum and that's a difference? The A's are the same, the B's are the same, just one has got a plus sign in between, one's got a minus sign. Then I know that O and I are going to give opposites. So what's the benefit? If I know that ahead of time, I don't need to actually multiply them. So what we do here, if we get these sums and differences, we just take the A times A. We do first times first, gives us A squared. And we do last times last, which gives us B squared. And because they are opposites, a positive times a negative, this will always be a negative there. Okay, so we'll kind of get through some examples of this. A phrase you might hear in later courses is conjugates, and then that's essentially a term to identify that everything is the same. So like A plus B and A minus B, we would call those conjugates of one another. Okay, so all these examples are of that. We'll do this first one here, kind of the long way. So I go x times x gives me x squared, so we're just going to FOIL this. X times negative 4 gives me negative 4x. So that was distributing the x to both of those things over here. And now we'll distribute the 4 to both those things. So positive 4 times x gives me 4x. And 4 times 4 is 16, but in this case, a positive times a negative gives me negative 16. So we see that these two things then cancel out. Okay? So you get x squared minus 16. And that's the long way. But remember the shortcut. Because we're able to recognize right off the bat that this is a sum and this is a difference, and then the same terms, I know O and I will cancel. So x times x gives us x squared. And then positive 4 times negative 4 gives me negative 16. And that recognition allows me to kind of skip this step there. Now it's a minor step that allows us to skip, but eventually it becomes something that is nice to have. It shows up in a lot of other applications. So we're going to go through the rest of these, kind of doing the same thing. Okay, so these are conjugates. Here's the sum and here's the difference. So I'll take x times x. We do first times first, and then we do last times last. Okay, same thing here. First times first, and then last times last. Down here, it's the same thing. Now it's not just 1x anymore, it's 2x, but that's fine. So first times first gives me 4x squared, and then last times last gives me negative 9. 4 minus x, 4 plus x, so first times first, 16, last times last, negative x squared.
Thank you so very much.
Okay, now this one here, and this is something that you'll have to maybe eventually catch on to. These are difficult. These are hard to recognize that they're really what we're dealing with here. And this is the first thing you have to do. This here and that there look eerily similar. They're not opposites. They look eerily similar. Let's take a negative out of that one. And when I take a negative, I mean factor. So divide everything by negative. So I've got negative 1. Okay. And now if I divide, remember, if I take negative x and divide it by negative 1, it gives me positive x. If I divide negative 4 by negative 1, it gives me positive 4. And then I get x minus 4 over here in this second set of parentheses. And what happens is that you see that now this is a set of conjugates. So we can go first times first. So first times first is x times x gives me x squared. And then last times last gives me negative 16. And that's what would be replacing that set of parentheses, or that product. Remember, there's still this negative 1 out here. If I distribute that negative 1, I get negative x squared plus 16. Okay? So that's a quicker way of doing that problem. Now, if you can't see that, which is fine, okay, I've got a lot of advanced juniors and senior level students that still don't do that way. when they see something like that. They still say, well, I'll take negative x minus 4 and x minus 4 and just FOIL it directly. So negative x times x, they get a negative x squared. They take negative x times negative 4, and it gives you positive 4x. Then they take negative 4 times x, so it gives you negative 4x. Then they go last times last, so it gives you positive 16. You recognize there that those become opposites, and you're left with negative x squared plus 16, which is exactly what we got over here using kind of the conjugate approach. Hopefully, that's a set of examples that are going to be beneficial for you in doing the homework. If you've got any questions about anything, don't hesitate to ask. Again, my purpose of this, or my thought, is that you are going to be taking your guided notes and working those guided notes as I go over these examples with you. Have a great rest of your day.